right, we will get started here. Okay, so my pleasure to introduce Sebastian. Sebastian did his undergrad here at UQ. Then he went over to Griffith for his PhD and a postdoc where he helped develop Fish ID. And now he's recently moved back over to the campus of UQ, but working with QCIF on their Sustainable Futures program. So he's going to do the acknowledgement of country, and with that, I'll just hand it over to him. Thank you.
Yeah, so my presentation today is about the work that we're doing on national scale data infrastructure. I could see this presentation as a starting point for this ongoing collaboration that we have between QCIF and CBCS. UQ historically has been an important partner for QCIF, and now that we're getting into this environment, climate, sustainable future space, this presentation will show you a little bit of the work that we've been doing. Cool. And just to do the acknowledgement of country, so I acknowledge the and celebrate the traditional owners of the land and pay our respect to the elders past, present, and emerging. I've been in the broader Nianjin land for the past 13 years, and I've called this place my home. I come from an indigenous lineage in South America, so I've developed a lot of respect towards Aboriginal culture, but how it can also influence the innovations that we do in the environment space. So as I mentioned at the coffee break, I'm an environmental data scientist, and I've been across all the experience that I'm showing there on the screen, mostly related to global or national scale projects. So my first role was here at UQ at the Global Change Institute. I spent there 4 years working with the Global Reef Record. So by the time, that that project was going on, it was the first baseline of coral reef images around the world. And UQ was leading that project. It was supported by the insurance company called Kathleen. Google was also involved, and UCN. In fact, if you go into Netflix, you can see some of the work that was done in that program. Can't remember exactly the Netflix show, but there's a Netflix show about that project. And my role there was as a database administrator. So it was grabbing all the images that were being collected with this underwater scooter, and then they were processed with AI. And we had these massive databases of images being processed with this artificial intelligence model. So it was very heavy, and my role was to make sure that the data was standardized, but also that it was made available to the researchers that were part of that team. That project then got released in the UQ systems, and then people can access it now. And then from there, other platforms have been built on. After that role, I moved into the Global Wetlands Project and Fish ID. Again, another global implication for innovative project at Griffith University. So for the Global Wetlands Project, it was a program supported by WWF, and the idea there was to develop spatial tools to monitor and to understand the conservation status of wetlands across the world. And then with Fish ID, it was a byproduct of the tools that we were developing there. But the idea there was to be Australia's digital platform for aquatic monitoring. So if you think about maybe the World Dogs project that I'm going to introduce later, it was if you throw a camera underwater, you process it with AI, and then how do you analyze that data essentially? Now that program was supported by federal funding here in Australia, but then it converted more into an international brand essentially, and most of our business was coming from international companies. So we're working with aquaculture companies, with NGOs that were doing monitoring rivers in Finland, for example, but also with the US government as well. And then all of this experience across spatial databases, AI, and so on, that led me to this role at QC. So I've been in this role for a month, and I'm leading this portfolio called Sustainable Futures, which I'm going to introduce in a bit. So to give a better understanding of what QCIF is, so QCIF, it's a non-for-profit public organization that it's owned by Queensland universities, and you can see universities there, UQ is there in the middle. And we serve exclusively those universities. So we provide all these services from advanced computing, skills development, data sciences, and enterprise solutions. You may have seen maybe at some point some of the like workshops that QCIF runs for R and Python. I did them myself when I was an undergrad, and that is an ongoing process of what QCIF does. But one of the spaces that such the CEO and myself and the team are getting now is in that national software platforms. So assisting researchers to develop this infrastructure, so then it's more interoperable and standardized across different areas. So the Sustainable Futures portfolio within QCIF is tackling those 4 components that you see there on the screen: environment, biodiversity, agriculture, and urban design, right? And it's all about developing data science tools, technology, data infrastructure across these pillars, right? And as I said, it's part of this QCIF Data Sciences and National Software Platform. So we receive most of the funding from the federal government, and then we assist the researchers to make sure that that infrastructure gets done at a scalable, in a scalable way. Cool. So why national infrastructure, right? As we know, in the environment space, the data that we are working with is disparate. Maybe it's coming from multiple sectors. The jurisdiction might be different. Some people own their private data and they share it, and the modalities might also be different, right? The data collection methods. Maybe you have an infrared camera or an underwater camera and so on, but then the data doesn't look the same. Yeah. So I think overall, the federal government, QCIF, UQ, all the people that are working in this space, I think they have seen that there's a critical need for digital infrastructure that matches and that it's consistent across the whole pipeline from data collection to data reporting. And the approach for this, which is, as I said, from the federal government, is Planet Research Data Commons. So if I want you to take something out of this talk apart from QCIF, is this program that is running that enables researchers to develop infrastructure at a national scale. So this initiative is enabled by the National Research Infrastructure for Australia, but it's managed by ARDC. So what Planet RDC, Planet Research Data Commons, is trying to do is to make models data more discoverable to the community across different jurisdictions and areas, right? So if we think about, for example, research, industry, and government, some of the times the data doesn't connect, right? The models don't connect, people are doing things separately. And what Planet RDC is trying to do is bring them all together into one space. Yeah. This will be difficult, obviously, but it's a really nice step towards making sure things are interoperable. Now, Planet RDC has 3 pillars, and I'm going to be presenting the 2 that are there further away from me. So the first one is the trusted environmental data and information supply chains. So this is all about how data is being collected, how is data going to be saved in storage and so on. Then we have the modeling decision support. So how is the data going to be modeled in what, which language, and where are the models going to be saved, right? Think about maybe environmental models that we are running all the time for different purposes. And then the final one is the machine observation data processing infrastructure. So how is the data going to be collected, and then how it's going to be shared across the modeling phases, and how it's going to be saved in the supply chains. And I've added there how much funding has been co-invested by ARDC into these programs to work as an incentive that this is an area that is rapidly evolving, and many of the researchers like you, like Matthew, are working with these frameworks to make their research a reality. So one of the platforms that I want to introduce as a case study of national infrastructure that QCIF is now leading and working in the modeling and analytics decision support space is EcoCommons. So EcoCommons is bringing together data and models from many years of funding, which was historically known as PCCBL and EcoCloud. Now it's all in one platform called EcoCommons. EcoCommons has been running for a few years. It was launched last year, and now it's part of the QCIF portfolio. And the key aspects of EcoCommons is that it's accessing data from other national infrastructure, like Atlas of New Australia, TERN, BOM, so all climate and environmental data in one spot. So you can just click and then say, I want this data for this space, for example. But then it's also giving access to algorithms, models, species distribution models, and others that have been co-developed with university partners and have been peer-reviewed. But because EcoCommons is bringing together a lot of the work that has been done through the years with PCCBL, it has also been peer-reviewed, in different journals. But it's one platform with different services. Right? One aspect that I covered here, so thousands of data sets, you can wrangle the data set, there's trusted models and algorithms, but one aspect here that's important from EcoCommons is that it's providing these virtual laboratories, right? So it's tackling users from the beginners to the more advanced. Right? From beginners, we will have point and click tools to run the species distribution models, but for more advanced people, we're also providing infrastructure to run these models at scale. Okay. Now, the next phase of EcoCommons that now QCIF is leading is to trying to engage with the community to co-develop and co-design new functionalities. So essentially, see as EcoCommons as a place where you can maybe publish your model that you have been developing for years, right? And this is an opportunity to establish that ongoing collaboration between CBCS and QCIF. And it could be from new functionalities, models, workflows, or even assisting with the training. So I've added there the support email that Raj here is helping with to make sure he monitors that, and then my personal email if that doesn't work. Now, the next platform at a national scale that will be now being built as a collaboration between QCIF and CBCS is this Wildlife Observatory of Australia, or WildOps. And that falls in the machine observation data processing infrastructure. And WildOps is essentially working with camera trap images and making a whole constituent pipeline from data collection in the camera trap space, in terrestrial context, at a national scale with that national objective. So this is a very simplified process or workflow of how WildOps will work. So people will, have these camera trap images that may be seen. They will go into a database. There will be computer vision AI models, that will be developed, and then you can use that to predict or to detect the species that you have there, right? But let me break down this a little bit more so you understand what are the key objectives or the new things that WildOps will achieve in this pipeline. So the first thing is that at a national scale, there's no database of camera trap images that people can access and then do their own AI models, for example. In an international scale, this has been done, but it's not happening in Australia. So the first idea here is that WildOps will develop a databases where you say species A has 1,500 images, species B 3,000, for example. And then people can use them or build or add more images towards that to help this national infrastructure, right? The second step is that once you have that database done, it will allow you to develop these AI models that, in their simple form, they require a lot of data that has been curated, that is consistent, and it's all in one space, right? So by having those detection models, then people can say, I have collected this data in my forest. I'm going to use this model that has already been trained to predict what animals they're visiting my patch, for example. Yeah. So again, this workflow has been done many times, right? But I just want to stress out that it's a national objective, trying to bring different jurisdictions together and trying to make this now available for everyone in different sectors. Yeah. Now, for me, the biggest component of what WildOps will achieve is that this AI component has been done, and as I said many times, but it's integrating with other national infrastructure. So if you think about in a terrestrial context, if you go from just having an image from a wallaby, and then now being able to report that image of a wallaby in Atlas of United Australia, you're having a whole standardized, complete framework from data collection to data reporting, right? And EcoCommons on its basic form, it's already consuming data from Atlas of United Australia and Turn, right? So collection of data, processing, reporting of that data, maybe modeling for different analytics and species distribution. So for me, this is like the most important aspect of what WildOps will achieve. It's integrating with the national infrastructure, and it will be super important to obviously get feedback from the community as well on how this will. And just to wrap this presentation, as I said, this portfolio in sustainable futures is grabbing a lot of the national infrastructure, helping researchers here at Q and other universities to develop these platforms, but it's all about the impact that this can have across sectors. So if you think about maybe biosecurity, if you are detecting feral pigs with WildOps and then you are modeling those species distribution models with EcoCommons, right? You now have maybe a biosecurity aspect. or using maybe some of the models that are eco-commons to inform a state of environment reporting, right? So the technology that is being developed here at a national scale can be applied for different sectors, for different impacts, and it will be up to the researchers to see how that would be fit, but we're trying to enable that impact. So yeah, thank you very much.
All right, I'll start off with a question, which is your prior work at Griffith. You said you had customers using your Fish ID platform.
Yeah.
Can you talk about how that worked? Because I think a lot of us in research, there's so many uses outside of just research.
Yeah.
Like environmental consultants are using this, government's using it to monitor hit their KPIs. So I'm new to that, and I'm interested in how that worked for you guys.
Yeah, sure. So Fish ID was supported by the predecessor of Planet Research Data Commons. And we were fortunate enough that Microsoft also supported us at Fish ID. The United Nations was also involved with its presentations and in FAO. So from a branding point of view, we were pretty much everywhere, right? Everyone knew who Fish ID was. And then that translating slowly that people were saying, hey, look, I have this situation that no one else is doing. And we saw that there was a space for that consultancy market, right? The good thing though is that most of that international market we could charge what we saw fit, right, for the work, and some of them would involve even traveling to places, doing the workshops and all that. But the business model for Fish ID was 3 phases. We have training. So it would be like, I'm gonna train you how to do AI models, whatever you wanna do, doesn't matter if it's Fish ID or not, but we'll train you for a specific amount. Then we will have what we will call consultants, in which we will train the person and then assist in the model development phases of, maybe they're just trying to detect salmon in a river, right? And then the other side of things was a full provider. So they don't have the time to do it, they just give us a specification, then we build absolutely everything from the data, from the models, from the data collection of those spaces. And when we, released that model, we saw more and more researchers being, happy with the services that we were being provided. And I think for us, it was really important once the US government started to get involved, the Florida Wildlife Commission, because, if you think about it, it's one of the biggest, organizations that is doing scientific work and decision-making in an important state in the US, right? And for us to be providing that service was super important. There was also another project that we were starting to get more and more, which was the sea cucumber monitoring. And in this case, it was just a remote operated vehicle that is swimming on the surface and trying to detect sea cucumbers. But the reason why we're doing that is because the industry, the sea cucumber industry at the Great Barrier Reef needs to report how many sea cucumbers they are taking and how many are in the environment, right? So that's another example of how this technology has a direct impact on reporting or development, right? But again, those were all different types of services in that business model that we have.
Another question?
Yeah, go ahead. Most of what you've been referring to here are individual observations as they go into the system. And I'm curious if there are other sorts of data types like movement data and whether any of these, how movement data fits in with them.
Yeah, to be determined. Like we especially for wild dogs, or maybe Atlas of Australia and so on. I mean, they do have some guidelines, but because we're in the process of developing this technology, these sort of conversations are important to determine what exactly is going to go into the platform. I think overall for us, it would be important to maintain that framework that Tern has developed with the data discovery portal, right? And we are consuming that data in eco-commons and so on. But it opens the opportunity for all to create another infrastructure board, or it could be just new functionalities in what exists. So yeah.
Is it just like national databases that feed into eco-commons, or are there like ones specific to particular states, like say Queensland's WildNet database?
Yeah, so both, national and then also local, but you also have the option to upload your own data set as well. So we have that flexibility and customization. I'm fully aware that maybe not everyone is working with national data. Local data is as important to, inform national stuff, so, yeah. Yeah.
Thanks for the presentation. It's super exciting to see all this coming together. I was just wondering about getting the data to you. So these images through laptops. So I worked for the state government in Victoria for a while, and they just had terabytes of these images. So I'm just wondering about that process in their case. How would they get that data to you all?
Yeah, to be determined. We had the same issue in Fish ID. So if you imagine you put a camera underwater and it's just recording there for hours or even for months, right? What you're collecting is a lot of raw data that maybe not be useful. One of the things that we do that maybe will be implemented in Waldos was what we call the fish no fish filter. So once you collect the data, we process everything and we just have these segments of that video where we have fish that are of interest to us, essentially. And then, you can then play around with all of the techniques like compression and all that to make sure that data transfer happens. Yeah, it will be one of the bigger challenges. Also making that data set available across different sectors. I would imagine that a consultancy that is working, closing down a mine, for example, maybe not want to share some of the data that they have. But yeah, that will be part of the process of working with stakeholders to see how it works. But yeah, good point. Yeah.
That's a good point. It's for cameras, we usually use images. It's actually less of a problem than the ecoacoustics people who do continuous recordings. They have way more data. But in the future, we might move to video once the AIs can use that as better. You mentioned that the consulting companies might not feel comfortable sharing their data, which is true, but there is a change at the federal government in terms of how they give and approve permissions to do things like mining, requiring the biodiversity data to be deposited.
Yeah, nice.
And so that's relatively new, but before that, when they made that rule, which I think it exists, they don't have there's nowhere for them to put the data. There is nowhere if you have camera drive data to put it. And they're doing something at the federal level called the biodiversity data repository, where all that will go, except for the camera trap and acoustic and these other more difficult data sets to deal with. So that is changing. Another thing too is like the wild net. So in Australia, even if you get a research permit, you're supposed to deposit your biodiversity occurrence data in WildNet as that's part of your research permit reporting obligations. But right now, they only accept a very basic type of data, like presence only data. So you couldn't use the WildNet data as it currently exists to do something like an occupancy model. You can only use it for species distribution modeling. And so one of the main objectives is to change how that works, not just for cameras, but for any systematic survey that has detection and non-detection data. So right now it's only presence only, never says if there was an absence.
Yeah, good point. Nothing to add to that.